Hey everyone, welcome back to the channel. In the last video, we covered stack. Today, we're going to learn about queue. These are the few topics that I'm going to cover today in this video. We'll be talking about introduction to queue, then the core operations, the method we have, which you will be using to implement the queues, which is already implemented in the queue, or inside the queue, you will be implementing it. And the simple queue, we'll implement it using array. We'll create ourselves. What are the methods we already have known while learning this part. We'll see what methods the queue contains. We'll see that here, and after that, that methods we will be creating ourselves here. We'll implement array. Using array, you'll create a queue, and will use linked list to create a queue. After that, this is a circular queue, which was introduced because there was some problem. There was a problem here in the queue, simple queue. Then that's why it was introduced. Now, why it was introduced, we'll be seeing that one after that. So these two things, these are implemented by us. We will be creating it because we are going to depth. We're going to see what the thing inside queue and how things are working inside it. We are going to see it by these five and three and five using that. But there is one thing in the sixth which is built in queue, which will give us something, but it won't say how things are going inside. So abstract class out of them, but it is a interface. Interface means like it will tell us what to do, but how it is happening in the backend, it's not gonna tell us. Like, or how this is gonna happen, it's not I am like specified. We can implement it using in. We'll talk more about interface in while explaining the sixth part. So it's a built-in queue. We'll also see that one. After that, Dequeue, it's a type of queue. Uh, then priority queue, which includes min heap and max heap. Okay. So we'll be covering all these things in this video. Plus, we'll see some interview type questions like how to approach a DSA problem and how to solve it. Okay, that's fine. Let's see that. Let's solve it. Okay. Now, let me tell you what is queue. Okay. So basically, let's say for example, one of the very common example while explaining queue, I'll explain that one, which is mostly you will be hearing if you are new to data structure. Then stay tuned. It is very simple and easy to understand. As the name suggests, queue means when you will a line, like when we go to a hotel or restaurant or some any place, like let's say uh, a movie ticket, let's say counter. This is a movie ticket counter. Let's say it's a movie ticket counter. uh, Someone is sitting here. Okay, let me draw it properly. This is a window. Some people is sitting here, and people are standing here in queue. Okay, so people are standing in queue, and let's say this is a queue, right? This is a queue. So people are entering from this side, and they are going to counter. So what is happening here is until and unless this won't get removed, this second place won't come. People will not, the second one won't be able to get it, right? So this guy who entered first is the guy who will go out of this line first. In first, out first, which means first in, then first out, called FIFO. This is one term you need to always remember while you're dealing with queue. means the data or the people who entered first is the person who will exit first. Okay, so here that is what happening. FIFO, it's called FIFO or LIFO. Let's say LIFO. There is one called LIFO, which means the person who entered last, this is the last person, is the person who will exit, will go out last. Out also last. Last in, last out, last means last in, which means let me uh, see, last in LIFO, LILO. Last in, last out. Okay, last in, last out. Okay, now mostly they will give you this term. Okay, FIFO. Cool. Okay, so now what we will see, next topic. Next topic is our operations. Here we have, which is called Enqueue, which is we have here Enqueue, Dequeue, and pick and the pool. Pool is similar to pick itself here, whether to find the last value or which is or not, like if there is a value present or not. We'll to identify that one. We have a pool as well. Let's say Enqueue, Enqueue, and we have Dequeue. We will be implementing this too. This is most important thing, means this is adding data, adding data, data, deleting data, or removing. Cool. Okay, Enqueue means adding a new data, and Dequeue means deleting a new data. But there is a catch. Let's say we are implementing queue using a array, for example. This is 0th place, 1, 2, 3, 4, 5. Entering into this enters from behind, rear, and exits from front. Let's say here we are entering some value, let's say a, so it will enter from here, it will go to till here, it will get stopped, and after that if any other value is there, then it will come here till next year, till like this. If you want to pop up something, so what will happen, this value will get removed, this value will get removed, and in simple queue this value will get removed, and this will become empty, and this will stay as it is. It won't swap, it won't come here, it will never come here, it will stay as it is. But if you do pop, let's say if you dequeue this, then this will get removed, then again you will do dequeue, this will get removed, this will get removed, but they will, if you have done 3 times dequeue, then this 3 will only get removed, and they will stay as it is in that place, they won't come to the here. Okay, don't think like that. And that was the problem, in simple queue. Now when, so it in normal queue 3 times I have done dequeue, so now it will look something like this. Now what happens if I try to enqueue again, now my queue will watch in the last place of this area. Now I can find a value here, there is some value present here, that means some value is in the end of the queue, that means queue is full, queue is full. even if it got removed, even if previously there was some values, right? Like now its queue is full, definitely it's full. Now what I'll do dequeue. Now I'll do dequeue here. Okay, now we have space, but even though the queue will tell the queue is not empty, it's not empty, we cannot enter here. So that was the problem. These spaces are getting like unused, they are putting unused, so therefore we have circular queue. Okay, now circular queue, what happens, what it does, it will it will calculate the length of this, and when if you want to put a new value here, let's say g, let's say you are adding g, so what will circular do, g will put the value here rather than swapping it and putting it here. G will come and put it g here, then h here, I here, like this. Now again it's full. Now if you do dequeue, then it will get removed again, like this. Or this one will get removed. After that, after calculating that one, this one will get removed. So not this one will, it will not remove now. Now what happens, if you do dequeue, then this will get removed. Okay, so it will round like this dequeue, and it will again continue like this in circular way. It will put the value and it will delete the value. Okay, so this was dequeue. Now what we're going to do, and queue is very simple. Queue is very simple like this. It will be an array like this. The data will be put, you will put the data in this format here, a, then some, if you want to a, b, c, d, and if you want to dequeue that, then data will go out from this place. A will get removed, then b will get removed, then c, then d, like this. It's very simple like that. Yeah, so now what we're going to do, it'll be implementing it. So now we will implement it. Okay, now we'll implement that one. Okay, so we have here we have pick, we have isEmpty. Yeah, this four only we have. Fine. Enqueue, Dequeue, peak is empty. No, fine. So before diving into the code, let me explain you something. Like before implementation, let me tell you what are the things required to implement it, implement the queue in the array, and why we are doing this one. Now you will ask me like how queue and this array is related, or if you have some questions like that, let me explain you that one as well. See, queue is an interface. Interface. What is interface? Now you'll ask me what is interface. There is two things. We have class and interface. Class is something that gives us everything inside it. Like we will tell us how a method, the method which are already present, means there is a run method, there is a delete method, there is a get method that is already defined, and from where that one we need to implement. Like for example, there is in a class we have an array, there is an array, and get, put, delete, all these methods are been done in that array. Now that is given us, that array is given us to us, and which is already pre-built, like these are already abstract in the Java built-in. These all things are already created in the class, and we create an object of that class to use those, right? To use those uh, methods, we just create an object of that class, like class A, class B, like that, and we just do a class A dot that any xyz method, and things works. But in interface, what happens, we are only provided with the methods, means what things we can do in that interface, that is only given, but how things, where things are being we need to do, that is not given. Means in this place, in the class, array is already written down in the class, which is abstract from us, like it, which is hidden from us. Already class is written, and all these methods are implemented in this array. But in interface, that array is not defined. This array in the class, and get, put, delete, these are implemented here, implemented in this array. Okay, but in interface, no array, only methods. Methods means how this the interface is gonna behave. Means what are the things like in queue we can do only we can do dequeue, Enqueue, peek, isEmpty. These are methods which are already which are present, and we are informed that these are the methods which we can perform, which we should perform in the queue. But how, where to perform? Can we perform in array? Yes, we can perform in array. We can use an array for that. And can we perform in the linked list? Yes, we can do that as well. Yeah. So in class, what happens? We simply, what do we do? In class, we do like this. We'll say class name equal class name A. We're getting an object new class name. So this is a format of creating an object. But in when we are working on interface, we do not write class name. We do not write this. We write where we need to implement. Can we if we want linked list, we write linked list. Okay. If we want to implement array list, we'll write array list. Okay. Now this thing array list, I'll be, if you haven't watched, then learn that one. It's linked list also. Do learn that one. Video is already available there. Now this is what interface is. Cool. Now let me tell you the how we'll implement it in array. So in array, what happens? Let's say this is an array. Okay. This is 0 plus 1 plus 2 plus 3 plus. We are going to put some value here. So first value will be here, and if you want to delete, this value will get removed from here. Okay. So what we did, first thing is the size of array. First thing is size or capacity. Cool. Okay. Then next is to make sure that there is 2 point here. In stack there was only one, right? There we were using top, which is to identify the index, and we need to manipulate it. Here there are 2 points. Here 2 openings are here. Here one opening is in front. Front is one opening. Front and back, the rear. So there are two things: rear, front. Third is we will use this front and rear, both the variable, to manipulate the index and to manipulate the data in it. So what we are going to do is, in the beginning, let's say if we have started freshly, queue array is starting from the beginning itself. So what happens? The array will not stand in the back. Array will help this. Sorry, this rearer will not stand in the back. This rearer will tell, using this rearer, will see whether the queue is full or not, until it will say, if this rearer is pointing to this place, then we'll say that the queue is full. If the rearer is pointing to this place, means we have still space. First we will see the size of this array. We have that variable for the whole size, we have that one. And if we see that rearer is less than size, means we have still spaces. So increment the rearer and put a value here. Means rearer will help us to put or add a value in the array. And what the work of front? To remove the value from front. So what will if you do dequeue? While enqueue, the rearer will help us to add a value. While dequeue means deleting a value, what happens? Simply this front will do incrementation here. The front will, now front is pointing to this, front will point here. So this value will remain as it is. How this is going to happen? Because let's say, for example, everything got dequeue. We did dequeue. Front is now here. Front is here now. So what happens? Again, front will go here. When front will again come here, it will replace this one. The rearer will get now Dequeue, when you'll do whole Dequeue, the rearer will come here again. It will start from here again and will replace the value in present here. That's how it will work. Okay, now let's build this queue. Okay, so I have created a folder, a package of queue, and inside that a class called queue array. So we are going to implement it using an array. So let's see that one. So first thing we need is in array, private array. Then we need in capacity and front int rearer. Okay, now a constructor. Now a constructor public queue. If you have some confusion in this part, like how I'm writing a class and what is constructor, then do watch the playlist, oops playlist as well, and you may find in this playlist as well. Okay, there's a specified playlist I have created for oops concept, which is based on whole thing related to this creating of class, creating of object, then how to create what is constructor, what is getter, setter, encapsulation, everything I have mentioned in that oops concept, like 5 pillars, 4 pillars of every of the oops concept. I have explained that one. Okay, I have also informed like what is this keyword. You need to make sure you need to know this keyword. This keyword means I'm identifying. This means inside this class, I want this capacity is equal to capacity, which is the value which is given to this uh, what is called parameter. It's called this parameter will come here. This one is this parameter, and this is related to this one. Okay. Now create a new array of this. Okay. Capacity. Cool. Then keep front. We want front to be 0 because we need to make sure whether um, whether the last whether we need, because it will help us to dequeue that one 0 and rearer to be -1, because now initially it will the queue will be empty. So if rearer is less than 0, if rearer is less than 0 or less than front, then it's empty. If it is rearer is equal to capacity, means capacity -1, because in array we need to have a minus capacity size, we need to minus size, and which will be equal to last index. So if it is less than minus capacity -1, then it's full. Now full, fine. This this one is done. Now we will do the enqueue, right? So public enqueue will put void. It will be void. Okay. We have some data. If let's say if it is, we need to check whether the queue is full or not. We need to find that one as well, right? So for that, what are we gonna do? We'll put whether the rearer is uh, equal to capacity minus, means if the capacity is, let's say size is 5, means the last index is 4. So if rearer is equal to the last index, then if it is equal to last index, then we can stop here. Do not do not enqueue, do not add anything here, right? So south is full. Fine. Okay. Else else let's add a value to it. Do one thing, like what we'll be doing, we'll increment it, increment the error plus 1, then array error is equal to data. Okay, so that's what we can do. Now enqueue will work. Now let's say public int dequeue. For dequeue there is no value, nothing required. If now we need to find out whether if it is empty or not. Okay, if so, how we can find whether it is empty or not? When rarer is, when front is greater than rarer, at that point of time it will be empty. So means when front will be in 0 and rarer will be in -1. So there is no value inside it, because rarers, if there is some value, then rarer should be in 0 or it should be in 1. So at that point there is not empty. Now if rarer is less than the front one, means if it is -1, in that only case when the rarer will be -1, then only it will be less than the front. So if front is less than, not equal, less than error, south is not q is t, and return -1. Else else just a front plus plus, that's it. Yeah, that's it. Okay, so front plus plus, and we can do like this. Return array front means it will return a front value, means with the 0th value, and after that it will increment the front. There are two ways of writing it. In simple way, let's say int equal to front equal to front. First we'll add a value of front, then front plus plus, we will increment the front, and after that return array index. Both will return same thing. Okay, to make it simple, I have done this. Okay, so this is the whole queue, array queue we have created. Now let me create a main class here. Now let's say queue array capacity, let's say 5. We have created an object of that. Then what we can do, q dot enqueue 21 q dot enqueue 22 23. Fine. Then q after putting its value, let's do Dequeue. Okay, let's run it. 21 and 22 will be the value. Okay, so what is happening? Q is empty, Q is empty. So okay, if front is greater than, means if the front is 0 and rear is -1, so it is greater than, then Q is empty. So see 21 and 22. Okay, so here what was problem? I just made it wrong. I explained you the right thing, but I just made it wrong here. Okay, when front will be one step ahead, means when the front will be in 0 at this point. See, we have kept front is 0 and rear is -1. So when this thing will get true, then this is the only point where it will be the queue will be empty. So we need to make sure when the front is greater than rear, if the front is greater than rear, queue is empty. Okay, that's it. Covered array implementation. Now, how this linked list is helpful to us, we'll see that one. Now you'll ask me, we have already covered this methods like enqueue, dequeue in array already. Then why would the need of linked list now? That will the first question you'll ask me. Then I'll tell you that one. See this. See here. For example, this is an array. 1, 2, 3, 4. This is fixed. We cannot add any more line here. Cannot add any more here. Can we do that? No, we cannot do that. But where else? If it is in linked list, we create a node. Now this is an head, and it will remain tail here as well. Tail currently, and we can add one, create a new node and add here. Tail will shift here. Then add new node. Then again new node. Then again new node. Come till end. Now this thing is called dynamic. We can store as much as node possible. Now this is called fixed. Understood? That's the reason why we need to implement linked list as well. I'll tell you how to do that one. Okay, see here. Let's say for example, this is a linked list. In the beginning, okay, let me clear this part. Let's say for example, the two things we need. One is linked list we want. Two is we have a head. Three is we have a tail. In beginning, we do not have anything. We have not created anything. First thing we will create is a node. We'll create a node. We'll define a node class. Then using that node class, we will create head and tail. Two nodes we will be creating, head and tail. Both will point at this point. Both are pointing to null. Okay, both nodes are pointing to null. Now what happens? Now if you do enqueue, what happens? We will create a linked list. We'll create a new node. Create a new node. Then add a value. Now while Enqueue, in this we'll put a parameter. We'll put a parameter here, and using that parameter, the data in that node we'll put that value. We'll put that value. Cool. Now what we'll be doing, if this had, if this tail, this tail is equal to null. See, what is happening here is we create a new node like this, and we'll put this data here. Now what happens? There is a tail and head. We'll make this head tail to point this, because tail is something that we'll use to add new nodes, and we'll count the node. We'll keep the counts of the node. Okay, and head will remain here in the front. Fine. So what we are going to do, we'll point both head and tail to this new node. So if tail is null, in the beginning it will be null. So at that point, what we'll do head is equal to tail is equal to this new data, new node. Cool. Understood why I am doing it. Then after some time, now the tail will no longer be empty. Sorry, no longer it will point to null. So again, what happens when you will do Enqueue again? At this point, it will get a new node. It will get a new node like this. Fine. What we will be doing? Create a new node, data to d2. Here, what we will be doing? Tail dot next, as tail is pointing here. Now, let's say, for example, tail is pointing here. Tail dot next means after this. Now it is pointing to null. Tail dot next equal to this new node. Fine. Means we have linked it like this. Pointing done. Now what we will do, we'll increment this tail to this. Now because this will be the tail, this will point to null. So this will be tail. So now you'll increment this tail. So tail equal to tail dot next. Fine, cool. Done. Our Enqueue is done. So next part is our Dequeue. Cool. In Dequeue, what happens? We already have some nodes. D1, D2, D3, D4. Means data 1, data 2, data 3, data 4. Till data 4. Now this is pointing to null. This is our tail. And this is head. If you do Dequeue, what we will do? We'll check if head is pointing to null or not. If head is pointing to null, that means this is empty. In the beginning, let's say in the beginning, or every head and tail both are pointing to the null. So if head is equal to null, so it's empty. Fine. Else if it is not empty, then what we will be doing? We'll just increment this to this part. Okay. So for that, we also need to return this value. So we'll store this value in the variable. After that, we will increment this, and we will check. if now if at this point head is pointing to null or not. Because if there is only one head which is pointing to null, and we have done Dequeue, then at that point head is pointing to null. Now both tail and head are pointing to null. So at that point we'll make sure that tail is also pointing to null, because in the beginning both will point to one head and one node. So if you do Dequeue here, now then head will point to null, tail will still point to there. So in Enqueue, what happens? It will create a new and if Enqueue, it will add. It won't say it's empty. Now at this point, head is pointing to null, which means after doing Dequeue, thing is gone. This data is gone, right? This data is gone. So we need to make sure that tail is also pointing to null after doing Dequeue at this point of time. Okay. So done. Now let's put the value of the head. In value is equal to head dot data, then done data, and then increment the head dot next is equal to, sorry, head equal to head dot next. Okay. Now what happens if head is equal to null? Means when it is a base case, when there is only one node present and the next is head, that node dot next is null. At that point, what happens? We need to make sure that tail is also next. Tail is also null. Okay. Else return. We have incremented the head and now return the value. Then Enqueue and Dequeue is done. Now we will implement this linked list part. Let's create a Java class linked list. Okay, so now do one thing. Okay, what we will be doing, we'll create a class. First, let's create a class. We need to create a class of node. First thing is create a class node. Inside node we have in data and node next. Okay, these two things we will be having here, and let's say and a constructor as well, public data is equal to this dot data is equal to data. Okay, so let's go to quick linked list. At this point, directly we can we need to create a tail and head, and tail and head we need to create that one. So node tail and the node head both are pointing to null at this point of time. So when we'll do Enqueue public, let's write a pointing to null. In start Enqueue public void Enqueue. Now what I'm going to do, now I need to check. Now I'm adding something, right? I'm adding something. That means I need to make sure that it's not yet full. I need to make sure it's empty. So also plus I need to but here it's not array, it's dynamic. I can put as much as node as possible. So here there's no need of checking whether it is full or not, as we are doing in array. Now what we need to make, so we need to make sure that tail is pointing, it's not pointing to null. I need to make sure that tail should, I need to make sure that tail and head are pointing to the perfect node, the beginning node. So if so first thing is there is no need of checking whether it is full or not, but we need to make sure that tail and head in the beginning tail and head should point to that first node. Means the tail will keep the tail will keep the track of the last node and head will keep the track of the first node. So here I will make the match of this. When the first node will be creating, we'll make the node of this. So first thing is create a node, new node is equal to new node data. Here in data. Okay, so if tail is equal to null, which is true in the first node when it is the first node, so at that point what we will do, head is equal to tail is equal to new node. Fine. After that, so when it's time for the second node, what happens, this will become false, and what we will do, we will create a new node. We have created the new node and we'll make that node attached to the tail dot next. So tail dot next is equal to new node. Then we have attached a new node in the end. Now we will increment the tail to that new node. So tail is equal to new node. Fine, done. So now we'll do public, this thing is done. Now Enqueue is done. Public int public int Dequeue. Now I need to make sure queue is not empty. Okay, so for that, what I'm going to see, what I'm going to check, I will check that whether the head is pointing to null or not. If the head is pointing to null, then it is empty. Okay, because in the beginning when we created the head, it was pointing at this point it is pointing to null. After that, when we added one node, at that point we made head to that new node. After that, there is no more changes. We have not made any changes. The change will be when we'll do Dequeue. Now at this point only the change will be there. So if head is equal to null, south empty and return -1. Okay, else what? Else we'll first put a value. So now what happens? Now we'll increment we'll increment the head to the next node. Before that, we also need to return what node we have just removed. So for that, we'll store the value of that node, head dot data. Now what we'll do? Now we'll increment it. Head is equal to head dot next. Okay. Now we'll check whether head is now pointing to, because if it is one single node, then the head will point to null now. So we need to make sure the tail should also point to null, because there is no more node present now. If head is equal to null, next tail is also equal to null. Okay, sorry, if tail is equal to null. Now return value. Done. Yeah, that's it. We have created a linked list queue. Now let's implement it. Let's just remove this. Done. Queue and queue and queue and queue. Dequeue. Let's see what will be the value. See, it's coming. So it's working perfectly fine. We can add one more. Then it will become, let's watch an error. there will be error in the last. See, in the last when we added 3, we have done dequeue 4 times, we have done already 3 times, then at last dequeue say queue is empty. If we add maximum so much, then also it will throw an error. See, okay, so we have not printed it. If you print it, then it will show error. Okay, so there will be no error because it's dynamic, right? It's gonna put all those things. So we have done 4 times Enqueue, sorry Dequeue. So the 4 times we have seen a value. So that, okay. So now we have completed LinkedList implementation using Enqueue. Now we'll see circular implementation, circular queue. What is circular queue? Why we have circular queue? It is very simple, and it is something related to array implementation of the queue. For example, let's say here we have a array. Let's say this is an array queue. While implementing the queue, let's say the size is this 0, 1, 2, 3, 4, 5. Okay, so array 5 is 5. Let's say for example at this 4 or 5 we have dequeue this 3 part, we have dequeue it. So what is happening now? This through 3 parts are vacant at this point. This is front, this is front, like this, it remains like this, right? And this is rear. Okay, what happened here? When we want to add something, when you do enqueue, it will check the last value in the simple array, linear array. It will check that last index. If the error is pointing to the last index, then it will tell us that it is full. It is not empty, it's full. There is no empty place remaining, but there is some empty places remaining here, right? These places are going waste. No use of these places now. So to overcome this problem, to use this place, we have something called circular queue. It is similar to array queue only. The only changes is we do not directly put the value in the index of rarer value. Now, if the rarer value is 5, we are not going to put the value in the 5. We'll do some calculation here and we'll modify the rarer value. So what will be that calculation? So the calculation will be like this. The rarer will be rarer plus 1, whatever value is currently, plus 1 modulo capacity. So what happens here? What happens here? Let's say for example at this point of time of rarer is 5. So rarer will be 5 here, right? So no, at this point of time 0, 1, 2, 3, 4. Rarer is 4, right? Rarer is 4. So 4 plus 1, which is 5, modulo 5. So answer will be 0. So now what happens? If you do enqueue something, then you need to put the value here. Okay, we'll put the value here. It will point you here. Go to array rearer, which is now 0, and put the value here. Now 6 come here. Then rarer will get again. Now let's say again here. Now rarer is 0. 0 plus 1 modulo 5. So the answer will be 1. So then rarer will become here. So 1 modulo 5, the answer comes 1. Cool. Fine. So 7 comes here. If you do Dequeue now, then what happens? Your front will increment here and your front will point here. Your front points here. When you do Dequeue, the front comes to here. Now this will be your error. Okay. So this is how it works. Fine. In circular format. Okay. So there is very few changes we need to make here in the code. Let's go to QArray. Here, in place of this, in place of else error, we need to put some sets of error is equal to error plus 1 in bracket modulo capacity. Let's remove this part. That data. That's it. And what we will do here is we'll put a size here as well. Why size? To make sure whether the queue is empty or not. For example, let's say size is because of this. Now let's say if you want to, there is a function called, right, there is a method of is empty or not. To make sure that to use that one, we also need to use size. Now size is 0 at this point of time in the beginning. Then we'll increment the size here. Okay. And when we'll dequeue something, then we'll decrement the size as well. Similarly, for here what happens here is in the front part, what we'll do is in value we'll store the current value of the front. Means when you'll do dequeue, you'll store the current value of the front array front and int. Then see, we have this value. Let's say, for example, we have done dequeue this one. Then in the beginning we have done dequeue of this. We did dequeue done. So we need to return this value as well. So we need to store that value. Let's say this is not 6. Let's say we have 1 at this point of time. Think of that like this. Let me draw that. Let me draw that for you. Let's say this is 1, 2, 3, 4. Now we want to dequeue this one. Front is here, F is here, error is here, and size is also here. Okay, as per the error, size goes on. Okay, so size remains here. It will remain here. It will check how many spaces are there. So when we'll do dequeue something here, size will decrease here. That will tell us one dequeue means size minus. So one dequeue will tell us there is one space left. So there is only one space is there. So that will make sure we can efficiently use error. Else it's full. Okay, else it's full. That's the case. Understood? So here what happens? Let me do some changes here. Here error, if in place of error, if size is equal to capacity directly, because if size comes to at this point, this is full. Okay, when you do minus, then it is equal to error. We can do what we can do. We can enqueue something. And let's say for example, we want to remove this one. We have removed it. If you remove it, we'll store a value of this front value first, and then we'll increment here. How we are not going to increment it like that. So how we are going to? We are not going to increment by incrementing it. This is the way. This is also a way. But here we are talking about circular. We are talking about circular. So even this, while the error is also circulating, the front will also get circulated. So at this point, we'll use the same formula for this as well. Front plus 1 modulo capacity. Cool. Okay. Size is equal to done. That this part is done. Then we'll put it here. Then what we'll do? Okay. Front is equal to front plus 1 modulo capacity. Done this part, and once we calculated the front place, what we will be doing? We'll do front. Once we have calculated the front place, we'll increment the front. Incrementing the front is also done. Simply return. Okay, so decrement the size as well, right? Decrement the size and return array value. Done. That's it. And our circular form is done. That's it. You can directly implement it. See, let's say for example, 1 2 3 4 5, we have done 5 Enqueue, then Dequeue, then again we will put some value. Okay, capacity. Hope there will be no error here. Okay, so array index out of bound. Okay, we need to make sure whether if it is empty. So we need to use a function as well here. Public boolean is pt1 empty. We need to check that part as well. If size equal to 0, then return true, else false. Same thing only. We are just returning this value, right? There was very small error. Yeah, see, it's coming out. There was very small error. What was that? Yeah. So now what we will do? Now next part will be working on built-in queue classes. Okay, built-in queue class is something like this. See, queue, we have done queue, queue1 is equal to new queue. We cannot do that. We cannot do this. In place of this, we can do linked list. We can do like this, and we can implement like this. Yeah. Offer. Offer means to enqueue. In built-in class queue class, it's offer. Offer 23. Let's remove this. Offer 23. 25 and 24, and it tells pool for removing it. Queue south queue dot pool. One dot pool. Okay, we also have this queue dot pick. Okay, let's see. 23, 23, 24, popped up, and then the pick was remain 25. Cool. Done. So this is what everything we can talk. Then we have Dequeue and private queue as well. Max queue, private queue, and everything. And that we will talk in our next video. Cool. Thank you.